So first we're going to review some properties of exponents that are from Algebra 1. And we have product of powers, which is where you're multiplying two powers with the same base. In order to use these rules, the bases must be the same. So when you're multiplying, what you do with the exponents is you add them. So 4 raised to the third times 4 squared becomes 4 raised to the fifth. Power of a power, which is where you have something with an exponent raised to another exponent, and you multiply the exponent. So 2 cubed raised to the second power becomes 2 raised to the sixth. Power of a product, which is where you have two things being multiplied, a times b, and that's being raised to an exponent, and that exponent basically goes to each term that's being multiplied. So I think of it as distributing, but if you're going to say that, you have to be specific, and you have to say you're distributing to the exponent, okay? Because a lot of people make a mistake when they say that and they distribute it to the number. You're distributing it to the exponent. So like here, you're not multiplying 4 times 3, you're multiplying 4 times the exponent on the 3, which is 1. So it would be 3 to the 4th times 5 to the 4th. And if any of those had variables to it, you would, exponents to it, you would multiply it with that exponent. A negative exponent, basically to make that exponent a positive, it moves to the denominator, and if there's nothing left in the numerator, then it becomes a 1. So I have 6 raised to the negative 4th becomes 1 over 6 raised to the positive 4th. A key here is basically the shortcut I use to make a exponent positive. If it is negative, you move it. So if it's in the denominator, you would move it to the numerator. If it's in the numerator, you would move it to the denominator. So I'm going to do some with variables. We're going to get some here with variables. So let me do this. We have 2x raised to the negative third, y raised to the over y raised to the fourth, z raised to the negative second. So basically, you move anything that has a negative exponent. And you have to understand here with the numerator, it's just the x that's being raised to negative 3. So the 2 stays in the numerator. The x moves to the denominator, and now that comes x to the third. The y has a positive exponent. That's going to stay in the denominator. And the z has a negative exponent. That's going to move, and that comes up top. And you would have it like this. The 0 exponent, anything raised to a 0 power becomes 1. So 12 raised to the 0 is 1. A raised to the m over a raised to the n. This is a quotient of powers. And as long as the bases are the same, again, you subtract the exponents. Just like when you were multiplying, you add the exponents. When you're dividing, you subtract the exponents. So this becomes 5 raised to the 5 minus 2, which is 3. So 5 raised to the third. And I'm going to do another example over here real quick to show you a shortcut. And I'm going to use variables. So the shortcut basically is just subtract the 2. So the 2 exponents, so 4 minus 2 is 2, and the term stays where the larger exponent is. So this is going to be x squared in the numerator because the larger exponent's in the numerator. For this one, you have 7 minus 5 is 2, so it becomes y squared, but that's in the denominator because the larger exponent's in the denominator. The technical rule would be 4 minus 2 is 2, and 5 minus 7 is negative 2. But then it's a negative exponent and has to move to the denominator, so you can kind of skip that step if you follow that shortcut. Just subtract the 2 and keep the term where the larger exponent was. But in order to use that shortcut, all the exponents have to be a positive first. Okay, so you'd make all the exponents positive by moving them like we did in the previous one, and then you can subtract them and use that shortcut. All right. The power of a quotient is very similar to the power of a product. This exponent is being distributed to each exponent in the numerator, to each exponent in the denominator. So it would become 3 squared over 4 squared. So I'll do a couple quick examples here. We have r over p raised to the negative fifth squared. And there's a lot of different ways you can get to the right simplified form. There's different steps that you could follow. Like for this one, I could use a power of a quotient first and distribute this 2 to my exponents, or I could get rid of this negative first and move that to the numerator. Either way I do it, as long as you follow the steps correctly, you should end up with the same answer. So I'm going to do the power of a quotient first and distribute to the exponents, and that becomes r squared over p raised to the negative 10. Now to make that a positive exponent, I move it to the numerator, and I get r squared p to the 10th. For this next one thing a lot of people forget with this part, when I'm distributing to the exponents, you have to distribute to the coefficient's exponent as well, not to the coefficient itself. So that doesn't become 14, that becomes 7 squared. And then this is going to be b raised to the negative 6th, b raised to the 5th, b raised to the 6th. I'm sorry, b raised to the 1st. So this is going to be 49, b raised to the negative 6th times b raised to the 6th. You can add these now, and that becomes 49 b raised to the 0, which just becomes 1. So it's 49 times 1 simplifies to just 49. This one became b to the 6th from adding these two. Remember, when it's just a variable, it's raised to the 1st. So that became b to the 6th. And then negative 6 plus positive 6 becomes 0. When I do this one, I'm going to distribute to the exponents in the numerator. Understand that this exponent is just on what's inside this parentheses. So I'm only distributing to those exponents. So that becomes x squared, y to the 4th, over x cubed, y raised to the negative 1. I like to get all my exponents positive first. So I'm going to have y to the 4th. This y becomes y to the 1st. And I have x cubed down in the denominator. So now I'm going to subtract these two. 3 minus 2 is 1. But it's going to stay in the denominator, x to the 1st, because that's where the larger exponent was. And then I can add these two. Again, this is a 1, so that's y to the 5th over x. That's my simplified form. Okay, so go ahead and try these 3. You can pause it for a little bit, and I'll give you the answers. Okay, so I have the answers here, and I showed you the work as well. Understand this one is really a negative 1 out in front, and when negative 1 is raised to the 5th, it's still a negative 1 because that 5 is odd. That exponent is odd. It stays a negative. So then this became y to the 10th, and then these two became y to the 12th, and you added 12 and negative 12 becomes 0. So it's negative 1 times 1, which is negative 1. So here's a couple of questions doing operations with polynomials. And this is where all these rules will apply within all these types of problems. So one thing here with the coefficients, understand they're not the exponent. So when I have 2 times 3, I'm actually multiplying 2 times 3. Those are my coefficients. I actually multiply them. A raised to the negative 2 times a raised to the 3rd. Well, that's going to become a raised to the 1st because I'm adding them. Negative 2 plus 3 is positive 1. B squared, c raised to the negative 2, and then that part can simplify. So I'm going to have 6ab squared over c squared, and the c moved to the denominator. You have simplified form when they're simplified the coefficients. if they're both here, like 2 times 3 is 6, or if it's a fraction, say I had a 3 over here, 6 over 3 would reduce or simplify to just 2. One of each variable, you've combined all the variables, so you only have one of each variable. There's no negative exponents, and you have no power of a power. So for this second one, this is q raised to the 7th in the denominator. So I have q squared over q raised to the 7th. That becomes q raised to the 5th in the denominator, because that's where the larger one is. And 4 minus 3 is 1, r to the first in the numerator, and that's it. And this third one, so I'm going to first distribute this exponent to the exponent, so it's not being multiplied with -2, but it's being -2 raised to the third, a raised to the 12th, b raised to the 6th. So, and then -2 raised to the third, that's going to become -8. Because the exponent is odd, that stays a negative. A to the 12th, b to the 6th, that's my simplified form. So we're going to determine if an expression is a polynomial. So for this first one, 1/4 x to the 4th y to the 3rd minus 8x to the 5th. So for this next one, we're going to determine if an expression is a polynomial and determine what the degree is. The degree is going to be the highest exponent when it's from standard form. The highest exponent goes down in descending order to the lowest exponent or the constant. So for this first one, all of my exponents are positive whole numbers, so this is a polynomial. And you may see here that the highest exponent is 5, but because these two exponents are in the same term, the degree of that term is 7, which means the degree of this polynomial, that's going to be the highest degree. So the degree is 7. You add the two exponents. If they're in the same term, you would add the two exponents to find the degree. This second one is not a polynomial because the variable is in a radical. And this last one is not a polynomial because the exponent is negative. Even if you would change this to 1 over x to the 3rd, if there's ever a variable in the denominator, that's not a polynomial either. So we're going to simplify these expressions, and this is basically the same as when we were simplifying complex numbers. You're just combining your like terms. I always just take them out of the parentheses. The first one's going to stay the same, but because this is a minus, I'm going to distribute that negative to each term in that parentheses. So it's going to be negative 2x squared minus 3x minus 1. And now combine my like terms. 4x squared minus 2x squared becomes 2x squared. Negative 5x, negative 3x becomes negative 8x. And then positive 6. And this actually becomes a plus 1. So that's going to be positive 7. For this next one, it's just combining like terms. It's a plus, same thing. 6x squared minus 4x squared becomes 2x squared. Negative 7x, positive 9x becomes 2x, positive 2x. And positive 8, negative 5 becomes positive 3. When you're multiplying, the same as before, you're just distributing to each term in the parentheses. So I first have 3x times 2x squared. Well, that's going to become 6, and this becomes x to the 3rd because remember we're adding our exponents. And then negative 12x, and that becomes squared, and then this one becomes plus 18x. And the same thing here. I'm going to distribute this n squared to both first, so that becomes into the 3rd, plus 2n squared, and then I'm going to distribute the 4 to both, so that becomes plus 4n squared plus 8n minus 6n minus 12. And now you combine your like terms. These two combine, so I have n to the third plus 6n squared plus 2n minus 12. Okay, so here's some you try problems. Go ahead and try these on your own. If you wait 5 seconds, I'll give you the answers, and then I'll go over them if you need more explanation. Okay, so here are the answers. First one, negative 14x squared over y cubed. The second one simplifies to negative 5c to the third over d to the fourth. And I'm not going to read every one, but you see these answers, and I'm going to take some time and go over them if you need them. If not, you're done. Good job. See you later. Okay, let me give you a joke here. What kind of bird steals soap from the bathtub? Rubber ducks. Back at it. Rubber ducks. Stick 'em up. All right, so for this first one, the two coefficients, you're going to multiply to get negative 14. The x's, I'm adding negative 3 plus 5. And then the y's, I'm adding positive 3 and negative 6. So that's going to become negative 14, x to the second, y to the negative third. And because you have this negative 3 as the exponent, that moves to the denominator. So I have negative 14 x squared over y to the positive third. This 14 stays in the numerator because the coefficient itself is a negative, not the exponent. You only move it if the exponent is a negative. So for the second one, the coefficients, I'm actually going to divide, not subtract, because they're not the exponents, they're the coefficients. So that becomes negative 5. The c's, c to the fifth over c squared, I'm subtracting. So that becomes c to the third. And the d, I'm subtracting as well. 7 minus 3 is 4, but it's going to stay in the denominator because that's where the larger exponent is. Number 3, you got to move that, basically distribute this exponent to each exponent. Distribute this 5 to all the exponents. So I have negative 2 raised to the fifth x, and this becomes x to the 15th, 3 times 5. This becomes y to the 10th, 2 times 5. And the z exponent is a 1, so that becomes a 5. And then negative 2 raised to the fifth, it's odd, so it stays a negative. 32 is 2 times itself 5 times. So negative 32, x to the 15th, y to the 10th, over z to the 5th. For this third one, you're combining like terms, or I'm sorry, the fourth one, you're combining like terms. So I'm going to rewrite it, but I got to remember I'm distributing this into each part. So that's negative x squared minus 2x and minus 5. Now I'm combining all of them. The negative x squared becomes negative 2x squared. Negative 3x, negative 2x becomes negative 5x. And positive 4 and negative 5 become negative 1. For number 5, I'm distributing this monomial that's out in front, and I'm distributing it to all 3. So I have 4 over 3 times 6, and that's going to become x squared times x squared. Add the exponent, so that's going to be x to the 4th. Plus 4 over 3 times 9, and that's going to be x squared times x, which is x to the 3rd, and then minus 4 over 3 times 12 times negative 12, so that's going to become a positive there.
and that's just going to be x squared. So when I multiply, you can do it two ways. This is 6 over 1 multiplying fractions. You can multiply straight across. 24 over 3 becomes 8. Or you can cross cancel. The 3 goes into 6 twice. This is once. So 2 times 4 is 8. X to the 4th. 3 goes into 9 3 times. So this becomes 4 times 3 is 12. X to the 3rd. And I'll do this one the other way. So I have negative times negative is positive. 48 divided by 3, which becomes 16. So that's plus 16x squared. And that's the simplified form. And so for this one, it's a little bit different than what you saw, but you're still doing the same thing. The concept is the same. I'm distributing each term to each part in the other polynomial. So first distribute the x squared, then distribute the 2x, then distribute the negative 3. So I have x squared times 2x squared is going to become 2x to the 4th because I'm adding those exponents. X squared times negative 4x becomes negative 4x, and that's going to become to the 3rd. And x squared times 5 is 5x squared. So the next one I do, instead of just getting long one and keep going, I'm going to start, because it's a little bit more, I'm going to start lining them up with its like terms. So I'm distributing this 2x now. 2x times 4x squared becomes 4x cubed. And I'm putting it under the x cubed part because they're going to combine. 2x times negative 4x becomes negative 8x squared. And 2x times 5 becomes positive 10x. And now I'm going to distribute the 3. And I have negative 3 times 2x squared is negative 6x squared. And I'm going to put that under the x squared. Negative 3 times negative 4 becomes positive 12, and that's going to be x, positive 12x. And then negative 3 times positive 5 becomes negative 15. And now, when you combine them, everything lines up. 2x to the 4th minus, these cancel out actually. So this combines to be negative 9x squared. These two combine to be positive 22x and minus 15. And that's all of the U-tries. If you have any more questions, ask me in class, or you can come to tutoring.